Good morning, students. In the previous class, we see some non-homogeneous linear equations solution. We know already tell what is meant by non-homogeneous and homogeneous. In the previous whole exercise, we see all are non-homogeneous. Now that we move the next exercise. The next exercise is the homogeneous linear equations. So the heading is homogeneous. Homogeneous linear equations. What is meant by homogeneous linear equations? Suppose a 2 equation or 3 equations is given. All the constants are 0 is called a homogeneous linear equations. I'll give an example. In previous, 2x plus 3y plus 5z is equal to suppose 3. X plus y plus z is equal to minus 3. Minus 2x plus y minus z is equal to suppose 0. We say the system of equation is called a non-homogeneous because we see the RHS, these two values are constants. Suppose these two values also become 0 is called a homogeneous linear equations. In the previous classes, we see all are non-homogeneous linear equations. Any one of the question RHS have some number, they except 0, is called a non-homogeneous linear equations. Linear equations means a system of equation contains all the RHS are 0. The system of 3 equations, the constant fully becomes 0. We say this type of equation is called a homogeneous linear equations. Now in the last example 1.7, fully we say the homogeneous linear equations. RHS fully contains 0, that is all the constants are 0. Then we say the system of equation is called homogeneous. Homogeneous linear equations. In this homogeneous linear equation, the system is always, important one more question, is consistent. But in a non-homogeneous equation, it may be consistent or inconsistent. But in a homogeneous linear equation, the system is always consistent. That is, always is possible to find the solution. Because all the RHS are 0. It has some values. So, homogeneous linear equations is always consistent. And in this case also, how to find the solution? It may be the rank 3 or less than 3. Here before, in a non-homogeneous linear equations, we can write in the matrix form as Ax is equal to B. But to convert it is in matrix form, how to write? We write, suppose this equation is given 2, 3, 5. Second equation 1, 1, 1. Third equation minus 2, 1, minus 1. Minus 2, 1, minus 1. And the next one is x, y, z. RHS over. What is the value of RHS? All the RHS are 0. So 0, 0, 0. Now we say it is of the form Ax is equal to 0. A matrix contains all values are 0 is called a 0 matrix. So Ax is equal to 0. Here before we write Ax is equal to B. Here also we use the value of B. But a matrix consists of all values of 0. I say it is Ax is equal to 0. So 0 matrix. Here before we write Ax is equal to B. Hereafter we use Ax is equal to 0. Then how to write the augmented matrix? Actually it's a value of A. RHS value is 0. So the augmented matrix is of the form we write is A by 0. Here before A bar B or A slash B. But here A slash all RHS are 0, we say it is A bar 0. So it is the augmented matrix. Here also some working rule to find the solution. Homogeneous linear equation, there will be a 2 case. Briefly, right? The one is a unique solution and the another one is infinitely many solution. I also introduce one solution. A solution set contains all values of 0 is called a trivial solution. Suppose we solve the equations. How many unknowns? X, Y and Z. 3 unknowns. Suppose the values of x is 0. After we find the value of x is 0. Y is 0. And Z also 0, suppose. So, all values are 0 is called a trivial solution. A solution set contains all values are 0 is called a trivial solution. Any one of them is non-zero is called a non-trivial. So is also important. A solution set contains all values are 0 is called a trivial solution. In a homogeneous linear equation, the system it may be trivial solution or non-trivial solution. What is meant by trivial solution? A solution consists of all values are 0 is called trivial. So in a homogeneous linear equations, it also contains a unique solution or more than one solution. More than one solution means infinitely many solutions. Now to write the working rule to find the solution of these homogeneous linear equations. Okay, the first head. Suppose a row of a by 0 or row of a both are is equal to 3. A by 0, that means augmented matrix, and the matrix A both are is equal to 3, where 3 is nothing but the given number of unknowns. Given number of unknowns. Both the rank is equal to 3 is equal to the given number of unknown. Then the system has unique solution, that is the system has a trivial solution. We already say what is meant by a trivial. The solutions 0, 0, 0. A solution set contains all values of 0 is called trivial. So the given system has a unique solution when the augmented matrix and the matrix A both are is equal to 3. We already say in a homogeneous system is always consistent. So is the first case. And the second case, suppose row of a by 0 and row of a is equal to 2, or it may be the 1 is less than the given number of unknown. It may be 2 or it may be 1. I write just 2. Or 1 is also less than the given number of unknown. Suppose both the rank should be 2 is less than number of unknown, then the system has infinitely many solutions. Both the rank it should be is equal to 2 or 1 is less than the given number of unknown, then the system has infinitely many solutions. So when the rank is 2 is possible, suppose the third row fully 0. So we have just 2 equations and 3 unknowns we can solve. So we already say we assign one variable as a constant. So in this case, we put the value of z is 3 where t belongs to r. In your choice, you will take any letter. Generally, we will take z is equal to t where t belongs to r. So just 2 types in a homogeneous linear equations. The first type is all the rank should be equal to 3. Then the system has unique trivial solution. The second case, suppose both the rank should be 2 or 1. Maximum the rank it will be 2. Then the system has infinitely many solutions. So we assign one variable as a constant. Suppose the rank is 1. We have only one equation and 3 unknowns. We know the working rule. We assign 2 variable as a constant. So just 2 types is the. In infinitely many solutions, the solution it may be the trivial and non-trivial. It may be the trivial or non-trivial. Trivial means all solutions set up 0. Non-trivial means it may be 0 or cannot be 0. Suppose a solution set contains 0, 0, 1. We say it is a non-trivial solution. Now in 1.7, you see the first question. Solve the following system of homogeneous equations. In one or two questions, the homogeneous is not given, but in this question, the word is also given homogeneous equations. You see, 1, 2, 3 equations. In all the 3 equations, RH is 0. So we say it is a homogeneous equation. Now we solve the homogeneous equation. Solve means to find the values of x, y, z. What is the first step? The first step to convert the given system of equation in matrix form. The matrix form is coefficient of x, y, z in the first equation lies in the first row. 3, 2, 7. Second equation coefficient of x, y, z. 4, minus 3, minus 2. Third equation 5, 9, 23. The second matrix is x, y, z. The RHS matrices, all values are 0. You see, all the RHS of the 3 equations are 0. Now it is of the form AX is equal to, is a 0 matrix, so I say it is 0. It is of the form AX is equal to, we say it is a 0 matrix, 0 or 1, because all the RHS are 0. Here before we write AX is equal to B, because some numbers are occur. In this matrix all values are 0, so I say it is AX is equal to 0. After writing the form AX is equal to 0, what is the next step? To form an augmented matrix. The next step, the augmented matrix is actually the given matrix is A is extended by the RHS. Actually the RHS is all values are 0, so A by 0 or O. First you write the values of A. The values of A 3, 2, 7, 4, minus 3, minus 2, 5, 9, 23. So we write first of all 3, 2, 7, 4, minus 3, minus 2, 5, 9, 23. It should be extended by the another value is 0 matrix. So it contains all values are 0, 0, 0. Next, we do some process. The next step to convert this augmented matrix in echelon form. In echelon form, the first one is always non-zero. It's also a non-zero. If any one of the number in second row and third row lies 1, we interchange. So our simplification is easy process. But you see the first row, second row, third row. Fully all are the numbers except 1. So no chance to convert the number 3 become 1. So in this situation we write the first row as it is. So 3, 2, 7, 0. So this one is non-zero. The next step to convert this element become 0. Okay, the number 4 become 0. What is the process? Here the number 3 is not 1. So how to write R2? This lies, the number 4 lies in R2. Our motive is to convert this number become 0. So what is the process? We already seen this kind of sum. Suppose both the numbers are differ, we interchange the number in the rows. We multiply the interchanging the rows. That is, the second row is fully multiplied by the number 3 and the first row is fully multiplied by the number 4. So how to write R2? We write R2 as, okay, R2 means second row fully, 3 times of second row, 3 R2. Both have the same sign, so I put minus. First row fully multiplied by the another number, 4. So minus 4 times of R1. Now we check. We write R2 as 3 or 2. 3 4s are 12. Minus 4 3s are 12. 12 minus 12 is 0. Next, the number is there, minus 3. We write R2 as 3 or 2. I write here 3 into minus 3. 3 or 2 minus 4 times of minus 4 times of the corresponding element of minus 3 in R1 is 2. 3 into minus 9. 3 into minus 3 is minus 9. Minus 8. Minus 9 minus 8 is minus 17. Oh. The number minus 2 become. We write R2 as 3 R2. 3 into minus 2. 3 into minus 2 is minus 6. Minus 4 times of the corresponding element of minus 2 in R1 is 7. Minus 6. Minus 4 7s are 28. Minus 6 minus 28 is a minus 34. The number 0. We see all elements are 0 in all the rows. So whenever we multiply, all the number become 0 because 0 into any number is always 0. So it is also 0. What is our next step? After converting this element becomes 0, our next work is we convert this element is also become 0. But 5, 4, 3. So is your choice. We consider R3, R2 or R3, R1. Is your choice. I compare 4 and 3. 3 is a small number. So I will take R3 and R1. Is your choice. I will take R2 also. And the simplification process is easy. So I will take it is R1. Here also we see both the numbers are different. 5, 3. But our aim is to convert this number 5 become 0. So how to write R3? We write R3 as, okay, this R3 fully we write. I consider R1 and R3. The numbers are different, so we interchange the numbers. So the third row fully multiplied by the number 3. 3 or 3. Okay, this 3 or 3 minus. What is the reason to put minus? 3, 5 both have the same sign. To separate then only it become 0. So minus. So R1 fully multiplied by the number 5. So minus 5 R1. Now we check the first one. R3. 3 R3. 3 5s are 15. Minus 5 R1. Minus 5 3s are 15. 15 minus 15 is 0. Next. The number 9 become. Suppose the numbers are big, you put a sideward. How to change the number 9? We write R3 as 3 R3. So 3 R3 value is 9 minus 5 times of the corresponding element of 9 in R1 is 2. 3 9s are 27 minus 5 2s are 10. 27 minus 10 is a plus 17. Next, 23. Suppose the numbers are big, we put a side out. We write R3. How to write R3? 3 R3. So 3 times of R3 value is 23. 3 into 23. 3 R3 over. Minus 5. Minus 5 of the corresponding element of 23 in R1 is 7. 323 is 69 minus 35. Okay, 69 minus 35. We separate 9 minus 5. 9 minus 5 is 4. 6 minus 3 is 3. And it contains 0. R1 is also contains 0. So we do any process, it becomes 0. Suppose we have any doubt, we put one as sideward, then the answer is easy one. Now we see, we convert these two elements become 0. After we convert these two elements become 0, what is the next step? To convert in echelon form, the next step is to convert this element is also become 0. You have any idea? You see, we converted these two elements become 0. We consider only R2 and R3. Just we write R3 third row as the sum of the third row and the second row. What is the reason to add both the difference? 17 minus 17. So just we add these two rows, this element become 0. We convert that element become 0, minus 17 plus 17. So sign only differ. So just we write the third row fully, the sum of the third row and the second row. So the first two rows is no change. We write the first two row as it is 3, 2, 7, 0. Second row 0, minus 17, minus 34, 0. And we write R3 as, we write the fully R3 as the sum of R3 and R2. 0 plus 0 is 0. 17 minus 17, 0. Plus 34 minus 34 is 0. 0 plus 0 is also 0. Now you see it is exactly in echelon form. This one is non-zero, and at least the triangle shape of element become 0. So this one is in echelon form. We write it is in echelon form. Okay, and also now we check the rank. Okay, here row of A by 0 and row of A. What is the rank of the augmented matrix on the matrix A? Both the rank, I say it is a 2. You check. 1, 2 non-zero. You see the third row fully 0. Therefore, both the rank should be is equal to 2. Always in a homogeneous system is consistent. So there is no way to find inconsistent. Homogeneous is always consistent. So no need to write it is consistent. Row of A by 0 is equal to row of A is equal to 2, where 2 is nothing but less than the given number of unknowns. Is less than the given number of unknowns. You see in the working rule, it falls in the second case. The rank is 2. Therefore, the 2 is less than the number of unknown. Therefore, the system has infinitely many solutions. Therefore, the system has infinitely many solutions. The rank is less than 3, therefore the system has infinitely many solutions. The next step, to find the solution set. How to write? In this matrix form, again we converted in the system of equations. So we write see the first row is become the first equation 3, 2, 7, where 3 is a coefficient of x. So 3x plus 2y plus 7z is equal to 0. We use the equation, so I put it as equation 1. Okay. Next, the second row, it becomes the second equation. You see the first one is 0. 0 into x is 0. Minus 17 into y is minus 17y. Minus 34 into z is minus 34z. You see the RHS is 0. RHS is 0. Now you see in both the number 17 is common. 17 2s are 34. And also one minus is common, so I divide minus 17 on both sides. For our easy simplification, the number minus 17 is common, so I divide minus 17 on both sides. Then this equation becomes y plus 2z is equal to 0 by minus 17 is also 0. I put it is a second equation. Here any chance to frame a third equation? You see all are 0. Suppose we form 0 is equal to 0. So it has two equations. And how many unknowns? X, Y, Z. Two equations and three unknowns. How to solve? We can solve, we assign one variable as a constant. So generally we will be take the third variable Z is a T, where T is a real number, where T belongs to R. Now we use the value of Z in 1 or 2. We use in 2 because the 2 contains just 2 variable, 1 contains 3 variable. So equation 2 y plus 2t is equal to 0. Y plus 2, the value of Z is t, is equal to 0. What about y? Plus 2t goes to that side, minus 2t. So the value of y is minus 2t. So we have the value of Z and y. The next step to find the value of this x. So use the value of y and Z in the first equation. So 1 gives, equation 1 starting is 3x. So we write 3x plus 2y. 2. You see the value of y is minus 2t plus 7z. 7. The value of z will be taken is t is equal to 0. So 3x plus and minus is minus 2 to 4. So minus 40 plus 70 is equal to 0. 3x minus 40 plus 70 is a plus 3t. So 3x is equal to minus 3t. By cancelling this 3. So the value of x is minus t. So we have find the value of x, y and z. Therefore the solutions are. What is the value of x? The value of x is minus t. The value of y? The value of y is minus 2t. And we will take the value of z is t. Important, we write this value where t belongs to R. So the solution of the given system is x is equal to minus t, y is equal to minus t, minus 2t, and the value of z is equal to t. You see, the given system of a solution, it contains both trivial and non-trivial. I say it has a trivial solution and also non-trivial solution. Suppose we put the value of t is equal to 0. Whenever t is there, we replace t by 0. We see x value is 0, y value is 0, z value is also 0. It's a trivial solution. Suppose that I put the value of t is 1. Okay, we put the value of t is 1. What about x? Minus 1. Y? Minus 2. The value of z is 1. So it has an infinite many solution, means it contains two kind of solutions. They are trivial solution and non-trivial solution. In the same exercise, the second subdivision. Okay, the same three equations given. To solve the given system of a homogeneous equation. What is the first step? Always the first step is to convert the given system of equation in matrix form. The matrix form is, the matrix form of the given equation is, first equation coefficient of x, y, z, 2, 3, minus 1. Second equation coefficient of x, y, z, 1, minus 1, minus 2. 1, minus 1, minus 2. Third equation coefficient of x, y, z, 3, 1, 3. Next, we write the variables. X, y, z is equal to, RH is fully contains 0, 0, 0. So it's a 0 matrix. Now it is of the form AX is equal to 0. it is of the form AX is equal to, a matrix contains all values are 0. After writing it is of the form A is equal to 0, the next step is to form the augmented matrix. The augmented matrix is A bar 0. A is a given matrix. We extend by one column of 0. First we write the values of A. Okay, actually it is a value of A. The values of A, 2, 3, minus 1 lies in first row. 2, 3, minus 1. You see the second row, 1, minus 1, minus 2. 1, minus 1, minus 2. Third row, 3, 1, 3. It should be extended by the last column, 0. All values are 0. After writing the augmented matrix, the next step is to convert the augmented matrix in echelon form. So echelon form means this one is non-zero, and at least the triangle shape of element becomes 0. It is better to convert any chance the first row first column element become 1. If it is possible, we do the work. You see, there is a chance. Suppose we interchange R2 and R1. Then this element 1 goes in the place of R1. So our simplification process is 1. So that's why if any chance the number 2 become 1. In all the sums, if any chance to convert that element become 1. Suppose the number 1 is not there, except to 1, 4, 5 like this. So we leave as it is the first two. Now here there is a chance to convert in 1 in R1. So I interchange R1 and R2. I interchange R1 and R2. So the second row become first row. 1, minus 2, 0. And the first row become the second row. 2, 3, minus 1, 0. We do the process. R1 interchange R2. Next, third row we write 3, 1, 3, 0. So for our easy convenient, we interchange R1 and R2. The next step, to convert that element become 0. So this element become 0. So no change the first two. So we write the first two as it is. 1, minus 1, minus 2, 0. Our aim is to convert that element become 0. So now we consider R2 and R1. You see 2, 1. Suppose this element is also become 2. We separate that element become 0. So how to write R2? We write R2 as R2 minus 2 times of R1. Both the same sign, so minus. So we write R2 as R2 minus 2 times of R1. So now we check. 2 minus 2 ones are 2. 2 minus 2, 0. The number 3 become, how to write R2? 3 minus 2 times of R1. 3 minus 2 times of minus 1. So minus and minus is plus. 3 plus 2 is 5. This is a small number, so I directly write. Next, the number minus 1 become, we check how to write R2. We write R2 as R2 minus 2R1. So R2 minus 1. Minus 2 times of minus 2. Minus 2 times of minus 2. Minus to minus is plus. So 2 to are 4. 4 minus 1 is a 3. Is a plus 3. Minus 1. Minus 2 into minus 2 is plus 4. So 4 minus 1 is 3. All values are 0. So we do any process, it becomes 0. Okay, this process is over. After changing this element becomes 0, next we convert that element is also become 0. So we consider in which rows? R3 and either R1 or R2, which is easy one. The easy one is R1 because just our number 1 is there. So we take the easy rows. So we write R3 as R3 minus 3 times of R1, same sign, so minus. Suppose we multiply first row fully by the number 3, 3 minus 3 become 0. So we write R3 as R3 minus 3R1. We write third row fully, the third row minus 3 times of the first row. 3 minus 3 times of 1, minus 3 ones are 3. 3 minus 3 becomes 0. 1, the number 1 become. How to write R3? R3 minus 3 times of R1. 1 minus 3 times of minus 1. Minus 3 into minus 1 plus 3. Already here 1. So 1 plus 3 is 4. Now the number 3. How to write R3? R3 is 3 minus, okay, minus 3 times of R1. So 3 minus 3 of minus 2. Minus 3 of minus 2 is a plus 6. Plus 6 plus 3. So add we get 9. It's a small number, so I directly write the answer. Next one. 0, 0. Allah 0. We do any process, it becomes 0. So that value is become. So first row, second row is no problem. Our next aim is to convert that element is also become 0. So no change in the first row, second row. 1, minus 1, minus 2, 0. Second row, 0, 5, 3, 0. Our aim is to convert that element is 0. We change this two element becomes 0, we consider only R2 and R3. You see the number 5, 4. Different number. If different number is there, to convert that element becomes 0, what is the process? We interchange the number multiplication. So R3 fully multiplied by the number 5 and R2 fully multiplied by the number 4. So how to write R3? We write R3 as, that is the third row, as 5 times of R3. We interchange the number 5R3. Both have the same sign, so I put minus. And interchange number 4 times of R2, minus 4R2. I interchange the number multiplication. So we write the third row fully, 5 times of the third row, minus 4 times of the second row. First one all are 0, so no problem, is also 0. Now we check the number 4. How to write R3? 5R3, 5 4s are 20. Minus 4 times of 5, 4 5s are 20. 20 minus 20 is 0. Next, the number 9 become, we write R3 as 5R3. I write here 5, R3 value is 9, minus 4 times of, the corresponding element of 9 in R2 is 3. 9 5s are 45. Minus 12, 4 3s are 12. 45 minus 12 is 33. 45 minus 12 is 33. All values are 0, it is 0. Now you see it is in echelon form. It's 1. What is the triangle shape of element become? 0. So we write it is a echelon form. And you identify what is the rank of the both the augmented and the matrix A. What is the rank of the augmented matrix? Rank means the number of non-zero rows. 1, 2 is also a non-zero. You see one element 33 is occur. A row consists of all elements are 0, then only we say it is a 0 matrix. If any one of the element is non-zero, we say the row is also a non-zero row. 1, 2, 3 non-zero row. Suppose we consider the matrix A only. We leave the last column. The rank is also 3. 1, 2, 3. So row of A by 0 and row of A, both is equal to 3, is given the number of unknowns. Therefore, what are both the solution? it falls in the first case. It has unique solution and also the trivial solution. Rank of A by 0 and rank of A both are is equal to 3. Next, we write the rank. Row of A by 0 and row of A. Hala is equal to 3 here, where 3 is the number of unknowns. Number of unknowns means x, y, z. Both the rank is equal to 3. Therefore, the system has, both the rank is equal to 3, the system has unique solution. That is, the system has a trivial solution. In a homogeneous system, the rank is suppose exactly 3. Okay, the given number of unknowns is equal. Then the system is unique and also the system is a trivial solution. That is, the solutions are. We directly find the solutions. You know very well, trivial means all solutions are 0. X is equal to 0, y is equal to 0, and z also 0. Now you have one doubt. Sir, how to find all values as 0, sir? We can't convert the matrix form into the system of equation. Suppose we convert all the matrix form in the system of equation, all values become 0. But it is enough to write it is trivial means all values are 0. How the value of x, y, z as 0? I explained, but it is the answer. It is trivial means all solutions are 0. Now I explain how to become the value of x0, y0 and z0. Okay, now you see the augmented matrix. It is augmented matrix. We say it is a unique trivial solutions. Okay. The next step, we write the given system of equation. Okay, the given system of this matrix form in the equations form. Suppose we convert it in the equation form. What is the first equation? The first equation is x minus y minus 2z is equal to 0. Is the equation 1. What is the second equation? 5y plus 3z is equal to 0. Okay, this is third equation. What is the third equation? Second over, third equation 0, 0, 33z. So 33z is equal to RHS is 0. Okay, we frame the equation. You see directly the value of z is there. 33z is equal to 0 means what about z? The value of z is 0. Next, we use the value of z in the second equation. So 2 becomes 5y plus 3 of the value of z is 0. 5y is 0. So the value of y is also 0. We use the value z and y in 1. Okay, so 1 gives x minus y 0 minus 2, the value z also 0 is equal to 0. 0, 0. The value of x also 0. In your test or exam, don't write this way. You say it is trivial, then directly we write the answer of x equal to 0, y equal to 0, z equal to 0 is enough. I explained how to become x value 0, y value 0 and z value 0. So in a homogeneous, the both the rank is equal to 3 is the number of unknown means you just write the 3 lines. The system as unique, that is the system as trivial, then directly we write the answers x equal to 0, y equal to 0, z equal to 0. It is possible only when the given system has unique trivial solution. I explain how to become the value of x0, y0 and z0. Suppose we convert the given system of matrix form in the equations. we see all values are 0. Directly the value is at 0. Using the value of z, y is 0. And the value of x also is equal to 0. But in exam or test, no need to write these steps. We directly write the answer. The system has a unique and trivial means. The solutions are x equal to 0, y equal to 0 and z equal to 0. Okay, now in this video we see two sums involving a homogeneous linear equations. The same model question lies in example we try in our class note.